The final lesson in our Chapter 4, Aqueous Reactions and Solution Stoichiometry, taking a look at lesson number 6 on our Notepack page, Solution Stoichiometry and Titrations. Let's open the Notepack. Other tools you'll need out for today's lesson will be our calculator and, of course, something to write with. Periodic tables are handy as well. We'll have to look up some molar masses, I'm sure. When we begin finding our lesson, we finished lesson 5 on molarity. Lesson 6 is found on page 19 of our Notepack, so we're almost there. When we are working with solutions of known concentration, we use molarity and volume to determine the number of moles. When we know the known concentration, we can use molarity and volume to determine the number of moles. Remember, in our stoichiometry roadmap, the moles is the heart of our problem, the want over given ratio. No matter what the unit is we're given, our job is to always turn it into the mole. Let's take a closer look at our first example, a titration problem, a solution stoichiometry problem. I'll read it for us. How many grams of calcium hydroxide are needed to neutralize 25 mils of a 0.10 molar nitric acid? Of course, we need to begin with a balanced equation. The first time I read through a problem, I really just ignore the numbers and try to pull out the chemistry. Calcium hydroxide, calcium with its +2, hydroxide with its -1, so when I write its formula, CaOH taken twice, is being neutralized by nitric acid. Ic came from 8. We know hydrogen is the first name of an acid. The polyatomic ion nitrate is NO3 -1. Formula for our acid is HNO3. The pattern of change shows a double displacement. Calcium goes to nitrate, hydrogen goes to hydroxide. The driving force is making water for acid-base chemistry. I'll write water is HOH, +1 with a -1, hydroxide and hydrogen written in their ionic form. And the salt produced is calcium, still a +2, nitrate, still a -1, so we come up with CaNO3 taken twice. I can clearly see if there's 2 base ions, we will need 2 as a coefficient in front of the acid. To neutralize 2 bases, we'll need 2 acid ions, creating 2 water molecules. The ratio here, a 1:2 to 2:1 stoichiometric ratio. Let's tabulate underneath what we know and what we're looking for. We want to know how many grams of calcium hydroxide needed to neutralize 25 mils of a 0.1 molar acid solution. Our given is the numbers that we have for the nitric acid. The want is our calcium hydroxide. Knowing that molarity is a concentration unit that describes moles per liter, our journey has us find the mole ratio of want over given. Let's start, as we always do, with what we are given. I like to write down, in terms of molarity, that we know we have exactly 0.1 mole of the acid, HNO3, in every liter of solution. The very definition of molarity, there's exactly 0.1 mole per liter of solution. If I multiply that by the volume in a liter, I was given 25 mils, 0.025 liters. Just set that on top of a 1 so I can clearly see the liter unit canceling. When the liters cancel, I'm at the mole unit. Liter units are gone. Molarity times liter pulls out a mole. We are at the heart of our stoichiometry problem, our want over given ratio. We want to know the base. Its coefficient is a 1. Every 1 mole of calcium hydroxide requires 2 moles of nitric acid. the want over given. I want the base from the acid. 1/2 is our stoichiometric ratio. Now what we've ended up doing is canceling the moles of acid. We're at moles of base. To land at a gram unit, mole times molar mass, again that's just an old stoichiometry problem. The very definition of mole is definition of mole is grams over molar mass. So I'll need to go to work adding up a formula weight for our base. Calcium has a molar mass of 40. There are 2 oxygens at 16 apiece and a couple of hydrogens. Molar mass of our base is 74. There is 74 grams of calcium hydroxide in every 1 mole of calcium hydroxide. Step 1, molarity times volume pulled out moles. Step 2, the heart of our problem, our want over given stoichiometric ratio. Step 3, to land at a gram unit, we multiply by the molar mass. And let's hit to reach a common answer. Please hit with me. 0.1 times 0.025, molarity times liter, times the ratio of 1/2 times the molar mass of 74. The number of grams I find is 0.0925 grams of calcium hydroxide. It would take 0.0925 grams of base to completely neutralize 25 mils of a 0.1 molar nitric acid solution.